This is R.D. Sharma Solution Class 12 Chapter 15 Mean Value Theorems. Exercise is 15.1. Verify Rolle's theorem for the following function on the indicated interval fx is equal to sin x divided by e raised x on 0 till pi. So this is the domain being given. So the domain is 0 and pi. The first thing is sin x is in the numerator, e raised x in the denominator. That is sin x, e raised x in this 0 to pi. This is continuous also and they both are differentiable also. In this domain, continuity and differentiability of this function is established. Already we have seen this. The third thing is fa is equal to fb. What is a? 0. What is b? Pi. So we will check whether fa is equal to fb or f0 is equal to f pi. So we have sin 0 divided by e raised 0. Here we have sin pi divided by e raised pi. So e can be anything. What I am saying is e has a proper value. So sin 0 is 0, sin pi is also 0. So 0 by some value will always be 0. So we have fa and fb both are equal to 0. So they have equal value. The third thing, when you do all these three, say proving, then final thing comes is there is a c between 0 and pi which will give you the differentiation of this function as 0. That is f dash x is equal to 0. The x which will give this function differentiation as 0, that x will be c. And that c has to lie between 0 and pi. So this is fx sin x divided by e raised x, and f dash x. You can use the quotient formula, that is P by Q form. This quotient formula you can use, or you can use the product formula by taking this e raised x in the numerator. E raised x can go in the numerator. It will be e raised negative x. So this will be sin x multiplied by, you can do it in any way you want. I'm just taking that ex e raised minus x in the numerator and differentiating it using the product rule. So cos sin x will be cos x, then e raised minus x. Then I have to differentiate e raised minus x. And I know that a negative is going to come. So I'm not writing the sign here. E raised minus x will be minus, this e raised minus x will be e raised minus x. But minus x differentiation will be what? It will be minus 1. So this minus will be in between. Now we can take this e raised minus x common, and that will go in the denominator only. So we have cos x minus sin x divided by e raised x. And that has to be kept as 0. When you keep it as 0 or equate it as 0, as I said, e has certain value. E is a specific value. So the numerator will be 0. Cos x minus sin x is equal to 0. That means cos x will be equal to sin x. When you divide both by, say, cos, if you divide by sin, then you will have cot. So better you divide it by cos. So we have 10x is equal to 1. So when we have a value of like 10x equals 1, x has to be equal to pi by 4. It's 45 degrees. So tan 45 degree is 1. And this tan 45 degree or pi by 4 is actually lying between 0 and pi. This c is nothing but pi by 4. And we have verified also, because pi by 4 is indeed falling between 0 and pi. So let me show you how you have to write it. This is the way you have to go about writing. Okay, this is how Rolle's theorem is satisfied. Verify. Sin 3x, now we have to verify the theorem. Sin x, sin 3x, and the domain is also given 0 to pi. So let's make it as 1. First one is continuity, second is differentiability. You already know that. Continuity and differentiability of sine function is already established. It is always there. Now the domain is 0 to pi. So f0 and f pi, that is fa equals to fb, we would like to ascertain. So we have s sine 3 into 0. I'm just trying to check whether they are equal or not. On the right it will be sine 3 pi, and the sine 0 is 0, sine 3 pi is also 0. f0 is equal to f pi, fa is equal to fb. This is the third condition of Rolle's theorem that have been met. Next one is to differentiate this function, equate it to 0. Whichever value gives the function as 0, that is going to be c. And that c has to lie between 0 and pi. Let's verify that. We have sin 3x. Let us differentiate it first. Sin 3x is, differentiation of sin 3x is cos 3x, and 3x is 3. So 3 cos 3x is equal to 0. That means cos 3x is equal to 0. 3x is going to be 1. We know that cos pi by 2, cos 0 is 1, cos pi by 2 is 0. So this cos 90 is 0, cos 3 pi by 2 is 0. All these values are 0. So when you need x, you have to divide left and right hand side by 3. So we get x is equal to this pi, this 3 goes down. So you have 3 here. It will be pi by 6. Here you have 3 pi by, this is 3 gets cancelled, pi by 2, 5 pi by 6. All this goes and on. But the value which we are talking about, pi by 6, pi by 2, 5 pi by 6, all lie between 0 and pi. The first one is 30 degree. Then we have 90 degree. Then we have which 5 pi by 6. Just multiply it by 180 and divide it by pi. So you get 150 degree. All these are lying between these two. Now how we are going to write all of these, that is given here. I'm trying to show you the reference also, the solution also. We have to verify the Rolle's theorem for the following function on the indicated interval fx is equal to e raised 1 minus x square on -1 to 1. Now don't worry about whatever is above this e. We are interested in what? We are interested in exponential function, and we know that what is the exponential function saying? Continuity, exponential function is continuous also, and it is differentiable also. So say two conditions have been met. The third is fa is equal to fb. That is, you have to take a as -1, b as 1. fa is equal to fb. We have e raised 1 minus -1 whole square, that will give you 1 only, and on the right, that is fb, you have to put 1. So e raised 1 minus 1 square, so 1 minus 1 is 0. Here also e raised 1 minus 1 is 0, e raised 0. So you get 1. Anything with the power 0 is 1. Both are going to be equal to 1. fa is equal to fb. We have achieved that. So continuity, differentiability, fa is equal to fb. These are the three conditions of the Rolle's theorem that have been met. Next one is the differentiation, and then put it as 0. Whatever value will give you 0, that is going to be c, and that has to lie between -1 and 1. We have fx as e raised 1 minus x square. I am differentiating it. The exponential differentiation is exponential only. E raised 1 minus x square. Differentiation of 1 minus x square is minus 2x, negative 2x. So negative 2x will come here, and just put it as 0. As I said, e has a proper value, so it is not going to be 0. And this minus 2x equal to 0, that means x will be equal to 0. That this whole equation will only be 0 when x is equal to 0. And this 0 has to lie between -1 and 1. And we see that if you draw a number line, 0 is actually between -1 and 1. That means you have verified the Rolle's theorem. Let me show you this scenario or the reference solution which you have to adopt, you have to write. See, knowing is important, but letting others know that you know it by speaking or writing is more than important. Verify Rolle's theorem for the following function on the indicated interval fx is equal to log x square plus 2 minus log 3 on -1 to 1. So we will not write log like this. We'll try to simplify it. It will be log a minus log b. Log a minus log b is nothing but log a by b. We have log x square plus 2 and we have log 3. So you will get log x square plus 2 divided by 3. Log a by b. Now this log a by b is your function fx. So this log function is continuous and differentiable in -1 to 1 domain. So we have no problem in saying the first and second condition have already been met. Second one is the third step is to check whether fa is equal to fb. A you are going to put as -1, b you are going to put as 1. So log -1 whole square plus 2 by 3, log 1 square plus 2 by 3, both the cases, because square of a negative will be positive only. Both the time you will get log 3 by 3, log 3 by 3, 3 gets cancelled, log 1, log 1, log 1 is 0. The value of log 1 is 0. So fa also becomes equal to fb. Third condition of Rolle theorem has also been verified. Now the next thing which comes is the fourth part, which is the differentiation of this function and equating it to 0 and then computing the value of x, and that will be c only. That will be c, which will lie between -1 and 1. So we will differentiate it. Log x square plus 2 by 3, differentiation is 1 by x. Log x is 1 by x. So 3 goes up, x square plus 2 goes down. Then we have x square plus 2 divided by 3. 1 by 3 will remain like this. X square plus 2 differentiation is 2x by 3. 3 gets cancelled. You will get 2x divided by x square plus 2 and you have to equate it to 0. X square plus 2 will never ever be 0. So only 2x can be 0, and that will only be possible when x is equal to 0. So in all, if you put 2x, x square by 2x divided by x square plus 2 as 0, you'll get x as 0. So when you get x as 0, that is the value that has to lie between negative 1 and 1. And negative 1 to 1, 0 lies between negative 1 to 1. I hope you got the idea. So this log kind of function, we have simplified it. We have said it is continuous and differentiable. Then we took negative 1 and 1, place the value, try to find out that whether they are equal to one another or not, and they are actually equal. Then we differentiated it. We found x as 0 in between, and that is between negative 1 and 1. So c is equal to 0. Hence, the Rolle's theorem is verified also, and we have showed it also. But again, same thing, the way you are going to write it, because the solution, how you are going to represent it, write it, that is very important. So better is for me is to show you the proper way you are going to solve the question. This is your Rolle's theorem. So there are multiple exponential type we have seen. This log also we have seen. Verify Rolle's theorem for the following function on the indicated interval fx is equal to sin x plus cos x on 0 to pi by 2. So we have continuity and differentiability being established for sin x plus cos x. No worry about that. You can directly write they are continuous and differentiable. The third thing is going to be the fa is equal to fb or not. So just put 0 in this function and pi by 2 in this function and just try to verify whether they are equal or not. Sin 0 is 0, sin cos 0 is 1. Sin pi by 2 is 1, cos pi by 2 is 0. So both the sides you get 1. So fa is equal to fb, 1 on the both the sides. Now f dash x, sin x plus cos x. Differentiate it. Sin x will be cos x will be minus sin. Now put it as 0. So cos x will be equal to sin x. You will get 10x is 0 as we have done in the earlier question just now. Divide both sides by cos x. X will be equal to pi by 4 because 10x is equal to 1. When we have x equals to pi by 4, whether it is lying between 0 and pi by 2, 0 is 0, pi by 2 is 90 degree, pi by 4 is 45 degree in between. So this is how we have verified the Rolle's theorem. I have to show you the solution also, that is those who want to do by themselves, they can just have a look, they can have a reference. Now the next question which is coming is exactly like this, only sin and cos has been changed and there is sin 2x. So this is how you are going to, the procedure will remain same for all these questions which we are attempting. So we have sin x, we have sin 2x, they both are what? They both are sine functions. So they are already continuous and differentiable. The continuity differentiability, then you have to check for 0 and pi, they are going to give you same value. Then just differentiate it, it will be 2 cos x, sin 2x will be cos 2x and 2x differentiation will be 2. Now put it as 0. You can take 2 common and you can just say that 2 cannot be 0. So cos x plus cos 2x is going to be 0. So you will have cos x plus cos 2x as 0. And we have this cos x plus cos 2x 0. But you have, these are two different things. Cos 2x and cos x are not equal. So either change cos x in cos 2x or change cos 2x as cos x. So cos 2x can be written as 2 cos square x minus 1. So you will get a quadratic equation out of it. I am writing in place of cos 2x. It's 2 cos square x minus 1. One more thing I have to tell you, that cos 2x can be written as 1 minus 2 sin square x. That is also an option. But since we have cos x, I have written 2 cos square x minus 1. I am not making it as a quadratic equation. 2 cos square x plus cos x minus 1. Now you have 2 cos square x. This cos x can be written as 2 cos x minus 1 equals 0. You can take 2 cos x here. It will be cos x plus 1. You can take negative 1 common here. It will be cos x plus 1 again. We have two factors here. 2 cos x minus 1 and cos x plus 1. And just place it as 0. Cos x will be half. And this cos x is going to be minus 1, negative 1. This half and minus 1. So what will be the value of theta here if we put cos theta as half? Cos pi is negative 1. And cos, what is the value of cos pi by 3? The cos 60 degree, it is half. So we have two values here, pi by 3 and pi. But initially when we started this exercise, I intimated you that the corner points 0 and pi are not included. You have to find a value which is in between the 0 and pi. So you will take only pi by 3. You are not going to take pi. This will be pi by 3. So you can say that f dash c is equal to 0. When we put f dash x is equal to 0, c was between 0 and pi, and that value is pi by 3. That is nothing but your 60 degree. Again, the reference and the solution is provided to you. You can have a look, and this is the way you are going to write